In this video, I'm going to show you how you can set the price of an NFT that you're creating. And I'm going to show you 3 different ways of doing it. 1 is going to be not so common. 2 is going to be very common. So 2 very common ways of doing it, the most popular ways of doing it, and probably the best ways of doing it. And then 1 easier way, but that is not as common, not as practical. And before we do that, just make sure that you subscribe to the channel, that you have already clicked the like button of this awesome video. Also make sure to check out Moralis.io if you're interested in building dapps and want to build them faster and better than anyone else. Check out Moralis.io and join our Discord of amazing Web3 developers by checking out the links below. So first off, we're going to start off by the 2 ways that involves actual code. You're building your own NFTs using Solidity. We're going to do it in Remix. And you want to find out how to set the price of them, how to actually sell them. Because we've had a lot of videos previously about creating NFTs, creating NFT marketplaces, but not specifically how to set the price for them. And the third way, which we'll share in the end of the video, is how to do it using just a simple user interface, using one of the big platforms, marketplaces that are already out there. So make sure to fast forward to that. If you're not interested in coding at all, you just want to see it through the user interface, then you can do that as well. But most people that do big NFT projects, they will probably use their own marketplace because they can be in more control. And if you build your own NFT from scratch, like we've done here on the channel before, you're also more in control over the NFTs and the properties it has and how it works and so on. I hope you're excited to get started. Let's do it. All right, so the first solution we're going to check out is if you've built your own NFT, you've deployed your own NFT, and you have the smart contract. Now we're gonna build into this actual smart contract a mechanism to charge for minting the NFT. And this is not a very popular solution, to be honest, because the problem with this is that usually you want to mint your tokens beforehand because you want to be in control over what gets minted and how much. And of course, you can control that in other ways. You can set a max cap of in your mint function, for example. So let's say that we wanted to override, or rather we want to build a public mint function. And in this function, we're going to charge people for minting NFTs. And we're going to have amount, so how many they want to mint as an input. And this is going to be payable because they do pay for it. And then in here, we need to require that the, let's see, the amount is, let's do it like this, message the value is bigger or equal to amount times some price. So let's set up here, U into 256. Public constant price is equal to, let's say in ETH that they're gonna cost, let's just say 1 ETH for simplicity, okay? Constant price, all right. And then we're gonna take amount times price, and we're gonna say ether. So why can't I do that? Okay, let's just do like this then. 1 ether. Apparently it can't do that with variable, so I'm just going to multiply with 1 ether will be the same, but just to make sure that the unit is actually ether. So it will charge it price times amount, and if they have put that much into this function call, we're going to call mint, and we're going to mint the sword NFT because that's the only NFT we have. And we're going to mint the amount that they paid for. And message.sender will be the owner of these NFTs. Now, and by the way, this contract I've built in a previous video at Moralis, but it's a very simple ERC1155 contract from OpenZeppelin. The metadata is also explained in that video if you want to check it out, how I did that. I can link it below maybe. But it's called the Ultimate NFT Tutorial, I think. You can check it out on this channel. But the mint function is now that so that the user can pay to mint an NFT. It will mint the NFT, and this would work. The problem with it is, of course, that now as long as they pay for it, they can mint as many NFTs as they want. Maybe we don't want that. Maybe we want this NFT to be limited in some way. With using this solution, which as I said is not a very common solution, we could check, for example, we could say that, okay, let's say we have a mapping that maps from uint 256 to also uint 256. We call this limits or cap. Let's call it cap. And this will regulate how many we can mint of each NFT. So the sword is NFT number 0, but if you had another NFT here, for example, which was armor ID 1, we want to set the cap of that as well. So we can now set the cap of both of these, and we can do that in the constructor. We can set that cap for sword to be equal to 10, and cap for armor to be equal to 5. So now we put in these limits here, and now we just have to enforce them here. So we can require here as well that now I have to check, first of all, how many are already in existence and compare that to the cap, because we need to know not only how many they want to mint, but how many are actually in circulation currently. And to get the function for that, I just go to the ERC1155 contract that we imported, because I don't remember off the top of my head if there is such a function already. So let's see, we have balance of probably not. But okay, since there isn't such a function, let's rethink here. Let's say that this is instead of cap, this is now NFTs remaining. How should I call it? NFT. Let's call it tokens remaining. All right. And we'll check so that tokens remaining for, oh, I have to rename here as well. The tokens remaining for, we have to specify token ID, of course, because now we have multiple token IDs. So uint token ID and amount. Tokens remaining subtracted by amount should be larger or equal to 0. There is a problem here though, and that has to do with overflow and underflow of integers in Solidity. I'm not going to go into that here, but we should use safe math here. This is not safe, okay? Not safe to use because if an integer like this, unsigned integer, cannot be negative, okay? And that means when it does turn negative, it turns into a very, very big integer, which is not a very good thing in this case, all right? So let's actually do that. Let's bring in safe math. And I'm going to Google for safe math, open Zeppelin, because it doesn't take that much time. Here we have it. Open Zeppelin, safemath.sol. We're gonna bring in this URL, import this, like so. And we're gonna say, using safe math for uint 256. This will make sure that we can use the functions called sub for subtract instead of this normal minus. We can use subtract amount. So now we don't have to worry about that anymore, because now it's going to throw an error if this actually does overflow. And then we can actually do the mint. Now we also have to adjust this after the mint. So we're going to have to say that tokens remaining is equal to tokens remaining.sub amount. All right, so we set that to its new value. So if we mint 2, there will be 8 remaining and so on. But we're not going to mint sword instead. We're going to mint token ID. This should be set before we actually do the mint call. Safer that way. Now this is actually pretty safe. I mean, you should do your own research before you put this in production. I'm only throwing this together now. This thing actually would be better to set in the actual underscore mint function. Because we don't know, maybe, probably not, there is some other way around to run the underscore mint function. And then we could get around this, but in theory there should not be, because this is a private function. It can only be run from here, but who knows, when you have a long contract, there might be things that you're missing. But let's keep it like this for now. Now this would accomplish an actual price. You would get the value into your NFT contract. You just have to make sure that you can actually withdraw this. So we have to build a withdraw function, right? Maybe you can't see this. Withdraw function, so that you can actually withdraw ETH and make sure that you're the only one who can withdraw the ETH from this contract. All right. But this is one solution. We have made sure that people have to pay to mint NFTs, and we set a cap on how much they can mint. The problem with this is are multiple, actually. First of all, the problem is that you are not in control of what gets minted, when it gets minted, and how much gets minted. You can set the cap, but that's basically it. The other problem is that our token contract really gets quite complex quite fast, because we're mixing logic that has to do with the sale into the contract that should just handle the token, meaning transfers and, you know, that kind of thing. Because you have to add more than this mint, you have to add withdraw and so on. So you're mixing in really a marketplace, a place where you trade tokens into the actual token contract, which is not really how it was imagined in the beginning. So the more common way would be to build an actual marketplace contract that only takes care about selling the actual NFTs. And then you would create as many NFTs as you want, and you would put them into the marketplace contract for them to be sold. So you would mint all of the tokens you want in the constructor function, probably to yourself, and then you would transfer those to the marketplace. The marketplace would be able to sell those to people looking to buy them. So let's do that instead. So let's comment out all of this that we did. We're not going to use this here. Instead, we are going to call underscore mint here. We're going to remove this as well. We're going to remove price. All right, or we can rather comment that out in case we would like to use it later or something. We're going to mint in the constructor. We're going to mint sword, let's say, and we're going to mint one of them. Or let's say we mint 10 of them, okay? And this is now a fully functional token contract, as it was before we started modifying it. Now we're going to build a marketplace contract, and I actually have prepared that here. So let's see, where is this? NFT marketplace.sol. Here it is. And this has a few functions. First of all, it has the most important function, purchase NFT. And this does the same thing as we did in our previous function. It takes the ID you want to buy, the amount you want to buy of them. So if you want to buy ID 0 and you want to buy 2 of them, you can do that here. It's public, it's payable, and we require that, first of all, we have enough balance of this token to actually sell it. Meaning balance of this smart contract address. Now, the marketplace contract will be the owner of the NFTs that they are selling. So balance of NFT for this specific ID has to be bigger than the amount they're looking to purchase. And then we're requiring that they actually paid what we want to get paid. So here I set the price to just 0.1 ether. That's the amount that I want to get paid for each NFT. You could of course have a mapping with the prices for each token ID. Here I just set the fixed price. And then if all of this is true, we have enough balance of that specific NFT, and we have gotten the money, then we go ahead and we transfer the NFT from this marketplace, which is this, to message.sender, which is the purchaser, the buyer, and we transfer the ID with a specific amount. All right, and that's it. These other 2 functions are just, or 3 functions, just standard functions we need to add in order to tell the ERC contract that this is a smart contract that can handle NFTs. So these are just return statements and functions that we have to put into our contract according to this ERC 1155 receiver standard and ERC 165 standard. Because it was quite a common error before that people would transfer tokens to an address of a smart contract that wasn't capable of handling that smart contract. Because if you have deployed a smart contract that has no way of interacting with the token, then that contract can never transfer the token to someone else. It's stuck in that contract because the contract can only do what it's pre-programmed to do. And here, at least, we have a way to send NFTs. The problem would be if all of a sudden someone were to send other ERC 1155 tokens here. This marketplace is only made to deal with the specific token that we deployed. All right. You could build it so that it supports any NFT, of course, but this one supports only the one that we deploy. And I'll show you later on here. So we'll put the contract or NFT address, NFT contract address. Okay. So if you're interested in what these things are, maybe I should make a separate video about them, but you can find them by looking inside the ERC 1155 receiver and ERC 165 contract, also from OpenZeppelin. I import them here. All right. So let me show you how this would work. What we need to do first is to deploy the token first of all. So we deploy the token and it will mint 10 swords and give it to the creator, which is us. We're going to deploy the NFT. Let me move my face here. Deploy that. And now we're going to deploy the marketplace. Where is it? Why can't I find that here? Oh, there's some error. Yes. Of course, we have to input the contract address. So the contract address we find from the deploy tab, we can copy it down here. I'm going to add that into here. And now we can deploy this. Marketplace, deploy. And now if we check the NFTs, both are deployed now. The balance of our account, so let's load up our account address. Balance of our account for token ID 0 should be 10, which it is. I can zoom in a little bit more, but now you can't see the code very well. Is 10. Now I want to transfer these to the marketplace. So save transfer from. I want to transfer from this address. Was the owner address I copied up here. I want to transfer it to the marketplace address. I want to transfer to the marketplace. The token ID is 0. The amount is 10. I want to transfer all of those. Go ahead and transact. Let's just see if I can bring up the console here. Transact. I have to put empty data in here, which is an array, byte array, transfer. There we go. So now I am no longer the owner of these tokens. The marketplace, if I copy the marketplace address, is now the address, these 10 tokens. So now other people, let me switch address, and now I'm someone else, can go into the marketplace. They can purchase an NFT, let's say ID 0, which is what they want to buy. They want to buy 3 of them. That would be, then we have to calculate the price, 0.1 ether. You would of course have to build an interface for this so people can see it. We're gonna send 0.1 ether, or okay, I can't put in 0.1 ether here, so I would have to use Way and put in whatever that is in Way. You can use a Moralis tool to convert it. But I'm gonna send in 1 ether because I will send in too much. We don't care about too much. Purchase NFT, click on that. It goes through. Now let's see what my balance is. I'll have to copy my address. My balance should now be 3. I have now purchased 3 NFTs. The balance of the marketplace should be 7, right? Because they've sold 3 of them. Yes. And I can also tell you now, there's no function to check that, but the marketplace now has a balance of 1 ether because I used 1 ether to purchase, and that would have been stored within the marketplace contract. Now, I did not build a withdraw function, which you would also have to do in your marketplace contract if you want to get the ether out, which you usually want. So now those are stuck in here, but it's only test ether, so it's not real money. Luckily, I didn't screw up that bad. Now, that's the most popular way, I would say, if you're building your own token. You use a marketplace contract. And it's important to, of course, build this thoroughly, test it thoroughly, use all of the standards that you can use, and make sure that it's audited and so on if you're having a big sale. That's very important. So don't use this code for anything in production. Make sure to audit it and put some more effort into it, more than just this 10 minutes that I did here. Now, the third and also a very popular way of doing this is that you don't build your contract at all. You just mint your NFT using OpenSea or Rarible. So let's go to OpenSea. And you just create an NFT here by signing into your wallet. Let's see. And you drag and drop your item here. You put description. You put all of this, supply, boom, 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 blockchain. You create it. And then you sell it for whatever price you want on OpenSea. You use their marketplace. That's the most easy way of doing it. And maybe it's not the... I mean, if you're looking to have maximum control of everything, you want to use this in a game, or you want to specify the different attributes of the NFTs. You want to be in full control of the entire marketplace, and you don't need something like OpenSea. You can distribute them yourself. Then it's better to create your own marketplace contract because you don't have to share a cut with OpenSea. But this is the easiest and the most common way of doing it because it's just a user interface. You can, of course, build the user interface like this. We did that in a video, NFT minting video, or minting interface, something on this channel. So you can, of course, build an interface like this if you're looking to build a marketplace for NFTs. We also have a video for that, cloning Rarible, an entire video series here using Moralis. It only took like 24 hours or something. But that's it. Those are the three most common ways of setting a price of an NFT. I hope you enjoyed it. If you have any questions, any suggestions on what we should build here on the channel, leave them down in the comment section below. Thanks for watching. Make sure to hit the like button, subscribe to the channel, check out moralis.io for the fastest way to build dapps. Join our Discord community of awesome developers down below, and I'll see you in the next video. Thanks for watching, subscribe to the channel, and I'll see you next time.